Hey everyone, thanks for joining us today. We'll give everyone just a minute or so to log in, but you are in the right spot for today's CNCF Live Webinar, Serverless Containers, the Next Step in Cloud Native with Jason Smith from Google. So hang tight, get logged in, and we will get started in about 1 minute. All right, I think we can go ahead and get started. Our group is climbing. Welcome to today's CNCF Live Webinar. Again, I'm Libby Schultz with CNCF, and we are talking about serverless containers, the next step in cloud native today with Jason Smith, an app eco specialist at Google. A few housekeeping items before we get started. During the webinar, you're not able to speak, but there is a chat box. So feel free to pop your chats in there. Let us know where you're listening from and post any questions for Jason there. We'll get to as many as we can at the end. This is an official webinar of the CNCF and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of that Code of Conduct. And please be respectful of your fellow participants and presenters. Please also note that the recording and slides will be posted later today to the CNCF online programs page at community.cncf.io under online programs. They're also available via your registration link you used to watch today, as well as our online programs YouTube playlist on the CNCF channel. With that, I'm going to hand things over to Jason to kick off today's presentation. Take it away, Jason.
Thank you so much, Libby, and thank you everybody for joining. I truly appreciate it. Today we're going to talk a little bit about what I call serverless containers, or serverless containers, what I believe is the next step in cloud native. And we'll talk a little bit about what that means, what to look forward to, and we'll dive into a few other topics. Just by way of introduction, I am Jason Smith. You can call me Jay. I'm an application ecosystem specialist here at Google Cloud. Sometimes we call ourselves app mod specialists. There's a few different things we call ourselves. I call myself the cloud alchemist. I'm a Full Metal Alchemist fan. My dog's even named Winry, which is a character from the show, but I also say I like to transmute monolithic legacy applications into cloud native applications. So cloud alchemist. I'm actually going to be a 7-year Googler tomorrow, so that's something, Googleversary as we call it. You can follow me on Blue Sky if you want to. And I also have a serverless blog called thecloudisserverless.com, which will have a podcast component next year. So if you want to learn more about just serverless in general, I just kind of opine a little bit about the serverless environment and the landscape as I see it. So please, if you are employed to, please feel free to subscribe. Before we talk about serverless containers, we really just need to define what does serverless mean. And if I asked anybody here what serverless was, if I asked an AI agent what serverless was, anything like that, I'd probably get a variety of different answers. So it's important for us to kind of level set here. A very, let's call it clinical answer would be to build and run software without provisioning, managing, or maintaining physical or virtual machines. That's very, very technical answer and whatnot, but what does it actually mean? What does it mean when I'm using this serverless platform? What it really means is let's remove everything that distracts developers from creating value. When we as developers are working, or if we are supporting developers as operations specialists, architects, infrastructure architects, so on and so forth, our developers' jobs are to develop product, create something, whether it's, you know, for a science project, for a personal project, or for a major enterprise or startup. We want to create value. We want to remove things that distract. Developers, at the end of the day, what they really care about is, does my code run? Does my code do what it needs to do? Am I blocked on anything? Can I use my language of choice and my dependencies of choice? And do I have to learn anything about infrastructure? Like, do I need to figure out how to deploy VMs and load balancers and all that stuff, or can I just push the code and expect it to work? Serverless kind of promises a lot of this. So the promise of serverless is, of course, no servers. Now, I always say we've never figured out a way to actually deploy applications on the literal clouds. So yes, there are servers involved in serverless. And we have a lot of people who work in data centers to make sure those servers run. When we say serverless, we're not talking literally no servers. We're saying from the perspective of the end user, there's no servers. As far as they're concerned, everything's just magically happening. You know, they deploy their code and it works. They don't know what's going on behind the scenes, and it's easy. Elastic, they want to know that the application will just scale when it needs to, scale up and scale down. Portable, I need to be able to move the application from platform to platform. I don't want to have to feel like I am locked into a specific vendor because their platform or their way of bundling an application or something like that is unique and proprietary to their solution, so I have to use something different somewhere else. Service-based, microservices-based to be more specific. Event-driven, so we only want the application to scale up when something happens, whether that event be somebody pulling up an app and making an order, or just somebody visiting the website or making an API call. And then, of course, this is more of the business, less the technical side of serverless, but pay only for usage. You know, the people who pay the bill for our cloud infrastructure or whatnot would really like for us to know that we are only paying for what's used and we don't have a lot of idle workers sitting around. Now, serverless as a concept, you know, the first time the word serverless was used, like in any kind of conversation, was in the 90s. But as a concept, a modern concept, really, it didn't start until about 2015 when Lambda kind of came onto the scene. Lambda was kind of the first function as a service platform out there, at least the first commercially viable one. I'm sure there's been other ones that were built in a lab somewhere, but never really saw the light of day or never caught on. But when this product came out and the function as a service platform came out and that concept took over, that's when the term serverless really started to take off and that term became popularized. The downside is that serverless and FAS, or functions as a service, have been seen as interchangeable, and that has caused a lot of people to believe that serverless is broken, because there are a lot of limitations to serverless compute that that we just can't ignore. For example, there are a lot of language and library constraints. Let's say you're using a serverless vendor or a serverless platform, and it only supports a specific version of Python or a specific version of Go, or because of the way the runtime's written, you can't import certain libraries. And so now you're trying to figure out, okay, well, how do I have to use a different vendor? Do I have to rewrite my code? What does this look like? Hardware constraints. What if there's a limit on the amount of memory you can use? Even though the servers themselves are running, you know, several CPUs and GPUs and memory, there's, for some reason, the individual workloads have serious hardware constraints, bespoke packaging, zip files, whatever the opinion is, to run on their runtime, build and deploy patterns. The big ones that we often see, that I often see a lot of people say, is vendor lock-in and platform lock-in. While your code is the same, you know, it's your code, the way you deploy it will vary from vendor to vendor, because everyone has a different bespoke packaging, bespoke deployment patterns and whatnot. So what when you build your tooling, you tend to see a lot of lock-in to any specific vendor, any specific platform. And, you know, that's not really helpful. And in the name of open source and kind of these open standards, that doesn't really help with the development of these platforms. And that could be one of the reasons why serverless is broken, is because it is very opinionated onto how we deploy code without servers. As a result, we often see this doubting Tom here who will say, well, serverless isn't really, it's fun. It's it's a nice little glue, deploy a function, and it can trigger something or whatever. It's a nice little glue to app, but you can't really build real enterprise workloads on a serverless platform. Or it runs in the cloud, so that you can't use a private network, VPNs, any kind of thing like that. You can't save data because it's stateless by nature. You'll be constrained by the choice. You can't do long-running jobs. All of these things that make people believe that serverless is just kind of, it's a nice little tool, but you can't really use it to build anything big. Well, we have a few different opinions, and I specifically also have a few different opinions on what serverless is and what we need to change. One of them is that serverless is way more than just functions. As you can see here, I've listed some serverless databases out there. So we're looking outside of compute here even, that there are other forms of serverless that exist out there. What does that mean? So the idea of serverless is that there's no infrastructure to manage. So it's not limited to just compute. It's not limited to just application. You can have databases that have theoretically no infrastructure to manage from the end user perspective. Some of these serverless databases, what some of them have managed to do is that they have, what they've done is they've decoupled the storage layer from the application, or from like the querying layer, which is an application in of itself, or API or whatnot. Traditionally you'll just, we'll spin up a bunch of VMs, install the, start sharding the database across that, which isn't, it works, but it isn't great in terms of serverless scalability or whatnot, because you're managing VMs, you're managing, hard drives, whatnot. What these providers often do, or with some of these open source tools too, is that the storage, the data gets stored there, but then when you need to query it, then the querying APIs spin up, do what they need to do. But yeah, so we have a lot of other forms of serverless that's more than just functions. So, with this in mind, serverless, whether it be compute, data streaming, we'll see serverless AI in the near future. We need to accept that it's more than just functions, and we need to really break that mindset in order for us to move forward with building better serverless. On opinion number 2 here, that I believe, is that serverless should utilize containers for packaging. And we'll go a little bit later into some of that, and some of the usage, and also some of the kind of the new patterns we're starting to see. But for today, I believe serverless should be utilizing containers. When I talked earlier about some of that vendor lock-in that we see, I was talking a little bit about the idea that you have your code, but you're running it on their runtime, whatever the vendor is, whether it is a cloud vendor, one of the public clouds, whether it is a packaged tool that you use, something bespoke that you create yourself, you're usually running on their runtime. With containers, you get to bundle the runtime with your, with your libraries, with your code and whatnot, into one package, and then deploy that anywhere. So that makes it so much easier, and it uses a very standard, the Docker file is very standard, so you kind of avoid that vendor lock-in portion as well. And also just containers. I mean, here we're CNCF right now. I don't need to tell anybody here about how ubiquitous containers are at this point in time. There's so many tools out there on how to help you build containers, maintain containers, make them secure. So if we do that, we can leverage with serverless. We can leverage all of that benefit. I think it's very safe to say right now that containers are the package unit of the cloud. In the same way that, we used VMs for on-prem for many years, and then kind of we had this crux where we were starting to become a cloud environment, we being the tech community, and so we started doing VMs on the cloud, but then now we're starting to realize, well, for cloud native applications, we need to think beyond VMs, and containers are now that package unit. So why can't serverless utilize that? Obviously, Kubernetes is the de facto platform for running containers. So you might be saying, okay, well, why don't we just run serverless on, why don't we just run containers on Kubernetes like we do? And you absolutely can, and you should. Kubernetes is a great platform because it abstracts away infrastructure. That's one of the reasons why containers have taken over, is that we want to make applications easier to deploy on the cloud, migrate from region to region, server to server. So by abstracting away that infrastructure makes it significantly easier. Kubernetes has a declarative API, which makes it easy to leverage. And then, of course, that API is extensible. So if there is something that Kubernetes, upstream does not offer, I, as a developer team, whatnot, can extend it, create my own controllers, get it to do what I need it to do. And it provides a great backbone for all of that. But there is a caveat. Kubernetes is not a magic bullet. It does a lot of good things. It is a great platform, but it's not just, as this comic shows, one of my, favorite comics on the topic is it shows like sometimes this idea of, let's just move that to the cloud. Let's just use Kubernetes, as if I'm saying a magic spell. As if I say the magic word Kubernetes, all of a sudden my applications are going to be fine. Well, no, there's a lot of planning that comes into it, and a lot of onboarding and whatnot. When you learn Kubernetes and you can use it as a power user and whatnot, it absolutely makes your applications better. But we need to be honest about that experience. And the reality is, Kubernetes really isn't built for developers. It's built for operators, not for developers, though. Because this is what developers actually have to do when they want to leverage Kubernetes. Write code, build a Docker image, upload it into a registry, deploy service, expose the internet, all this fun stuff. At the end of the day, what they really want to do is just write code. If you were a developer who knew absolutely nothing about Kubernetes and you were told to learn something tomorrow, this would be that's not even a full list of all the concepts you would have to learn before you're ready to deploy an app. Maybe you don't have to learn every single aspect, but you have to learn a lot of it. And it becomes a question of, well, who's responsible for this? Like, as a operations manager or a platform engineer, am I responsible for making it as easy as possible, like writing bespoke code to make it super easy for the developers to not have to learn this stuff? Who's responsible for it? Who has to maintain it? Are we going to force the developers to have to learn how to do all this stuff? It is something that you have to think about, and a lot of people don't. So really, Kubernetes isn't actually for developers in and of itself. When we look at bare bones Kubernetes, it's not for developers because it's not the right abstraction for the end developer experience. But it's a great platform for building that abstraction on top of, which brings me to opinion 3. There is no reason serverless can't be portable. So what does that mean? Well, there should be a way for us to leverage Kubernetes, leverage the portable nature of Kubernetes and containers, and make it easy for developers to deploy on them without these bespoke tools. And that way, I can, with Kubernetes being as ubiquitous as it is, being as widely used as it is, and containers being the big standard, we can move, as developers, as teams, we can move our application from one organization or from one set of servers to another using Kubernetes, but we can also leverage these platforming tools to build that platform. So here I list 2, which we'll dive into, serverless options that exist that add that right level of that additional abstraction, that right level abstraction to developers on top of the Kubernetes abstraction. Both of these are open source CNCF projects. So Knative, I know some people pronounce it native. I honestly don't know. I think it's going to become like the big kubectl, kubectl, kubecontrol argument. So I'm not going to get into that one. But yeah, so it's an open source project. It was started by Google in 2018 and then donated to the CNCF. It's an incubating project right now. What it does is it offers a set of building blocks so you can actually build your own a fast or PaaS platform. So basically, it abstracts the common tasks through Kubernetes API objects to where a developer doesn't have to think about creating a service, creating an ingress, creating a PVC, anything like that to deploy the app. They just deploy the app with a simple YAML service, and it's good to go. And at the end of the day, it's still Kubernetes. It's running on top of Kubernetes, so you still get all the benefits of running Kubernetes, just without the, I don't want to call it headache, but burdening your developers with the running of Kubernetes or any kind of the Kubernetes knowledge that they don't need as developers. So Knative serving is one of the components of Knative. So the idea here is you have a service, which is an application. Think of service similar to pod in that concept. So service is the application you deploy, or think of it similar to a deployment in Kubernetes. When you deploy a service, what Knative serving will do automatically is it will create what we call a route and a configuration. So the route is essentially the ingress layer that routes the traffic to the proper service. Knative serving is as that operator is always running, it's always on, but the services themselves scale down to 0. It creates a route when a user pings that route or pings that IP address or whatnot. The route's what intercepts it, turns on the version, and then routes the traffic. Configuration manages the state of the application, so the workload specifications such as the container image to pull down, all that stuff, but it also manages revisions. So, you know, we're developers. We're going to be pushing new versions of the software every time, whether it's because of a feature request, addressing a bug, testing, so on and so forth. The configuration will also manage the revisions, which makes it easy to roll back to an older version if a new version causes some issue. So revision, think of it as like a snapshot of a previous version. There is also a component called eventing. And one of the ways to look at the eventing architecture is it is a way to abstract the event sources from their sink. So what does that mean? So an event source can be like a Kafka cluster or a Kafka topic. Traditionally, a lot of times when you're developing an application that connects to a Kafka or whatever service, you're having to kind of hard code some of that configuration. Knative eventing acts as kind of an abstraction layer between your application and those event sources. It allows you to declaratively bind an event source to a specific application or service. So rather than having to hard code all of that, I can just declare it. If something changes, we create a new topic or we need to update something, makes it super easy for me to just update the application by changing some of the basic source within Knative eventing. So it's really easy to bind stuff. That's really what it boils down to. It makes it super easy to bind event sources, whether it be Kafka, RabbitMQ, Kinesis, so on and so forth, PubSub, to your application without having to hard code it, because this is an abstraction between the two. So when we look at developer experience with Kubernetes, Knative, so you have your developers, you have the infrastructure which Kubernetes is handling, the primitives of Kubernetes, so things like ingresses, services, networking, TLS, all that fun stuff is being handled by Knative. And then what we've seen some people do is, you know, build some additional tooling on top of that just to make it a little easier. There's been some advancements in Knative to where you don't even have to do some of that anymore. So like Knative functions is a thing too nowadays. Or you can use an off-the-shelf thing like OpenFast, for example. But yeah, so basically it makes it super easy for developers to just push code and run on Kubernetes without having to learn a thing about Kubernetes. And for those of you who are nerds like myself, here's some architecture. Almost all of these I pulled from the knative.dev website. So please, I implore everybody to just go and look at that website if anything's curious. Great CNCF project. Another project that has graduated is called KEDA. Very similar to Knative in concept, but a different way of approaching it. So what it does instead is it scales actual deployment. So you still kind of deploy the application the same way you would any other Kubernetes one, but it handles the scaling because it's triggered by event queues such as Kafka or whatnot. And based on the traffic or what they see on the event queue, it will scale out the application automatically utilizing the Kubernetes autoscaler. And again, you install it right on top of Kubernetes. So under the hood, it is still Kubernetes. So you can still leverage a lot of the Kubernetes ecosystem that you want to continue leveraging. Maybe you want to use Backstage or you want to use Prometheus, whatever the case might be. So this kind of gives you a little bit of an idea of what this looks like. So you have the Kubernetes API server, you have KEDA operator installed. It will hit the horizontal pod autoscaler based on the amount of traffic, event traffic it's seeing. Now there is also like an HTTP component that you can install too that gives you some of that Knative similar feel, if you will. But this is a good idea of how it works. So we'll scale out the application to do more jobs based on an event queue, such as Kafka. So it automatically handles that scaling for you. So it makes it super easy for developers to develop applications that need to scale out. And this is by no means an exhaustive list of all the things that KEDA can use to scale out, but this is to give you like an idea of what it uses or what kind of metrics it utilizes to determine, oh, I need to tell the horizontal pod autoscaler to start scaling out. These are some of the sources that it considers. So we look a little bit to kind of, I guess, look back a little bit. We look a little bit at the benefit of serverless, but also kind of the evolution of compute as we think of it. Historically we thought about on-prem. If I'm a developer, if I'm a team and we're working on-prem, I have to think about things like internet connectivity. How do we get fiber to my data center and all that stuff? Installing network hardware such as switches, the literal physical security of everything, and then installing physical servers, putting them up on the racks, all that fun stuff. When we start looking at the cloud, what we've done is you've basically told the cloud provider, whoever that may be, hey, you handle the on-prem stuff. My responsibility now is scaling, VM provisioning, and managing the operations and security. So I have to provision the VMs. I need to figure out how to scale things out, and I need to figure out the ops and security management. But I don't have to install a network switch. I don't have to figure out a server. I don't have to figure out how to get fiber to my data center. With this new world of serverless, you've now pushed the cloud back to the vendor saying, okay, you handle the scaling, the VM provisioning. I don't even want to hear the word VM. I don't want to think about a VM. I just want to write my code, push it, and you handle all of that. And I also want but I also realize that from an SRE perspective, I have to monitor performance, or you should be. And I say cloud vendor, it could be a private cloud too. This isn't necessarily specific to the public cloud. From a developer perspective, they would say the same thing. Hey, you cloud provider, being your internal DevOps team that's running your private cloud, you worry about this stuff. As a developer, I want to take the serverless route. So to recap, at this point, developers want serverless. If you were to strip away the word serverless and just say, hey, developer, what do you want to do? I just want to write my code and I want to know that it runs. I don't want to have to think about infrastructure. So developers want serverless. Operators want Kubernetes because it is great at what it does. It's great at managing microservices and whatnot, but it's just not the right abstraction. We have actually seen an increase of the concept of serverless containers, which is what we've been talking about. These are containers that you can deploy on Kubernetes, utilizing tools like Knative and KEDA to make those containers serverless. We have started to see from a Datadog report that 45% of container organizations are now using serverless containers. And you can start to see that trend coming up right here. So if you're looking at like when Knative was open sourced in 2018, for example, we're looking here at September 21 up to September 23. We're getting close to 50% utilization there. Oh, and I also wanted to point out one thing about about the concept of serverless containers, because there are some, when I talk about serverless containers in general, we kind of get that doubting Tom person coming back saying like, well, nobody uses serverless containers at an enterprise level. Like, it still sounds very niche. It sounds very, gluey or whatnot. Like, oh, I want gluey in the sense of like, gluing things together. Gluing applications together. I don't think I can run an application, but I mean, despite the fact that we have these 45% of people saying that they are, we still have the doubting Toms. And so a lot of people just always say, well, tell me about a big company that's actually using serverless containers at scale. And I'm like, well, I mean, Google is. So our Borg system, which was kind of the basis for Kubernetes, is actually serverless containers, just kind of exposing a little bit of the insides of Google, but it's public information and whatnot. But basically, from our developers' perspective, it's serverless. They just deploy code and Borg handles everything. So we believe serverless containers is important. I think serverless containers in general is important because I think developers should be able to focus on the things that matter. And everything at Google is a container. So I say this not necessarily to position Google, just the idea that, look, these are applications that can handle billions of traffic. Serverless containers work. Serverless containers can work. It's not this idea of, well, serverless is this nebulous thing that can only be used as glue and can't scale out. It's like, well, maybe the traditional fast platform might have some limitations. If you containerize it, you could do it. You can make billion user apps, or you can make million user apps, and anything in between. Platform engineering is a super important term. So it's becoming a very important concept. And I wanted to touch a little bit about platform engineering with serverless. In the future, I'll probably look at either doing a blog post, video, whatever you want to call that goes into more detail, but I want to touch upon it because when we're talking about building serverless container environment, there is a little bit of an onus on the operators and platform engineers to kind of build that entire toolkit to make it easier for developers to build the serverless platform. What is that? What do I mean by that? Like, it's more than them just deploying containers. Anybody who's developed an application on the cloud will be able to tell you that a good portion of it isn't just, oh, I deploy an application. It's like, what about my databases? What about my Redis queue? What about this? What about that? What about security? There's a bunch of other things to think about. So you're looking at this entire platform and it's like, well, okay, how do I make the entirety of the platform, not just the compute, easier for the developers? And there are quite a few ways to do this. We'll touch upon a few. One thing I want to point out, so if you've ever gone to the CNCF landscape, you've probably seen the huge portion of products and projects, members, so on and so forth. There's actually, if you've never noticed before, there's actually a little tab for serverless, and this is some of the tools that exist out there today that CNCF recognizes. There are other tools out there and whatnot. I don't want to pretend like this is an exhaustive list of all the tools that exist. These are some very commonly used and accepted tools, though. We're going to touch upon a few of them specifically. We've already talked about KEDA and Knative. I want to talk a little bit about build packs, which isn't specific to serverless, but I think is important to talk about. Because one thing you might be asking me right now is like, well, you said you don't want developers to have to learn anything new, which is fair. But we still are going to have to teach them how to write a Docker file. And what I say is, well, what if we don't? What if we can still create a container without a Docker file? Build packs does just that. What build pack is it's essentially a set of executables that you can put into your Git repo, or if you're doing a local development, your local source folder, and it will essentially detect like what you're trying to build, Python code, Go code, whatnot, and build that Docker file for you in your CI/CD platforming or whatnot, and then build that container, put it in a registry, deploy it. So it basically makes it super easy for developers to do that. So this is an important, while it's not specific to serverless, like regular Kubernetes users can do this. I think this is an important component to serverless in terms of freeing up developer time so that they don't have to learn how to use a Docker file, but they can still reliably build a Docker file using an open standard. Dapper is a really cool project. It's a graduated project. One thing I like about it, while it's not a serverless platform per se, it is great for platform engineering in my mind, because what it does in a very basic mindset is that it kind of creates an API layer where you can create what are called building blocks. And it allows you to essentially declare as code the different cloud resources. So as an operations team, we can create these building blocks so that now the developers just make an API call this building block to, to spin up a GKE cluster, to spin up EKS, to spin up whatever resources, just declare it by code. And again, it runs on Kubernetes, so you don't have to like spin up specific VMs or anything like that. You can just deploy it on your Kubernetes cluster and it's good to go. So it makes it easier for developers to just kind of provision a database and have that ready to go so that I can connect to it. Wasm Cloud is something I want to talk a little bit about. I'm not going to go too deep into detail on this, just because Wasm technically isn't containers. Well, it isn't containers at all. It's something different. But I do think in the name of serverless, in the direction that we're seeing things going and how CNCF is starting to kind of look at Wasm, WebAssembly is the longer name. I do think it is important to talk a little bit about this in the name of serverless. So basically, Wasm Cloud is a way to build Wasm applications on the cloud. What some people are thinking about with Wasm is that it may, I don't want to say it'll surpass containers. I think realistically, both will exist in some way moving to the future, and they'll just have different use cases. It's like, I think KubeCon 2 or 3 weeks ago, whenever it was, I can't tell time, somebody during one of the keynotes mentioned that it's not going to be an either or thing. Like, containers didn't get rid of VMs. VMs still exist and they have a use case. Wasm's not going to get rid of containers. So they're going to exist. But I think from an application standpoint, they tend to be very small compared to containers, and in times can run faster. And Wasm Cloud makes it easy to build and develop these applications. So I think it's important to kind of talk about. So we get back to Doubting Thomas here. And what we see here is really, while his concerns are valid, we see that these limitations don't really exist when you think of serverless containers. I can build enterprise applications because this is a Kubernetes at the end of the day. I can leverage the security. I can run long-running jobs. I can use private networks, all of this stuff, because it is still built on top of Kubernetes. One thing I want to leave with, and then I want to also give people a chance to ask any questions in the chat, excuse me, is I'm convinced, is a quote that I like. It's I'm convinced the majority of people managing infrastructure just want PaaS, platform as a service. There's only one requirement. It has to be built by them, which was a quote from Kelsey Hightower. And I think that's really what we're looking at here, utilizing Kubernetes with some additional abstraction to create a serverless environment for developers, make it easy for them to deploy on the cloud, and deploy their components on the cloud, their applications on the cloud, and it's just work for them. So I don't know if we can do the Q&A or whatnot, but I do want to give people a chance to ask if they do. Otherwise, I can give a little bit. Oh, yes, yeah, please feel free to ask anything in the chat. And I also encourage checking out, I believe it's KEDA.sh, as well as knative.dev for those two projects to get like deep into them. Also in the CNCF chat, there are channels for both groups, if I'm not mistaken. So you can also ask questions there. if you want to dive really deep and whatnot. And I talk a little bit about the serverless eventing. If you go to, I believe, my blog, jasonsmith.io, I talk a little bit about that as well and have some demo code there. Some of it admittedly needs to be updated, but no questions? All right. If you don't have any, I'm happy to give time back.
All right. Let's give him one more second and see if there's any last minute questions, and yeah, then we'll wrap it up for today. Anyone? There you go.
Oh, here we go. What are the next big use cases for serverless containers? In what use cases are they being deployed? So serverless containers are still containers at the end of the day. So it's still a containerized app. What we're seeing when we say serverless containers is adding that additional abstraction layer to make it easier for people to deploy containers without having to create ingresses or any kind of Kubernetes object. And basically, we have the tooling that automatically builds that in abstraction from the developers. So I answer that way to say that what I've seen is that people are using Knative and whatnot to deploy containers that are the exact same way they've been deploying containers before they used Knative. What they are doing is they're just simplifying the experience for their developers so they can deploy faster. So it's literally the same basic application. Like the application you deploy on Knative is going to be the exact same application you would deploy on like just standard Kubernetes. It's just that you abstract away a lot of the Kubernetes away. It's a way to use serverless containers is a way to use Kubernetes without having to understand Kubernetes is a good way to look at it. I hope that answers your question. But ultimately, it's the same basic type of application. So it depends on your cluster. So basically, what you have is with tools like Knative Serving, for example, or even KEDA. What they do is they will, as they start to see traffic, they will spin up as many pods are as required to handle the traffic. You are able to set guardrails in your configuration to make sure it doesn't go to infinity or max out whatever the resources of your data center is. But it will automatically spin up as many pods that are required for the spikes. So again, it's still Kubernetes under the hood. You're just making it easier for developers by abstracting away all the Kubernetes-ness of Kubernetes. And thank you. I see we have a serverless team from Uber here, so thank you for joining. We've seen in a lot of examples, to go back to that earlier question, we've seen a few retail customers leverage serverless containers, even like on Black Fridays and whatnot, and it scales up because it still leverages the Kubernetes autoscaler, just abstracts away everything. Cold start problem technically will exist. There are ways to mitigate it, like by turning on and always on, like turning on a warm CPU if you're not. Sometimes what some people will do if they have pretty predictable traffic is that they will have at least one very small container running at all times, or one very small service running at all times. So that gives you a warm start. But yes, that is a very real problem with serverless containers, is the cold start, and really serverless in general. Honestly, I think that's one reason why WASM is starting to become looked at more, is because of the potential there to help alleviate some of the cold start problems by having smaller instances. But there are ways to mitigate it by having like a small instance always running, or by having there are some configurations you can do with CPU to have kind of a warmer setup, if you will, to where it will boot a little faster. It won't be as fast as always on with the CPU setting, but it's definitely faster than a pure cold start. The same as anything else. So at the end of, so going back to the serverless containers when running on top of Kubernetes, you would still secure everything the exact same way. And then also it leverages built-in TLS with Knative and whatnot. So you have that additional layer of security, but you're able to leverage any kind of security component that you want. Now, when we talk about like serverless vendors, like I showed some earlier, some open source projects like Neon Tech, which also have like a hosted version. Excuse me. They basically will help you. They have ways to secure with like keys and whatnot. You can still leverage security keys. It's the same way you would do any other security, any other encryption from a database on a Kubernetes instance. Any design considerations for providing serverless platform while utilizing multiple infrastructure providers? That is a good question. I think so. When it comes to serverless containers, it is a container at the end of the day, so that part makes it easier, virtue of the fact that hey, it's just a container. It doesn't. It's the same platform that I can deploy across multiple vendors. If you're using like the same, Knative or KEDA across the board, that makes it a little easier. Then when it comes to actually deploying and routing traffic, that becomes a bit of a different issue because now we're talking about like load balancers and CI/CD platform. But there are ways to do that. I would consider how you set up your load balancer and how you route the traffic would be a big consideration to consider if you're trying to route between multiple things. But at the end of the day, again, it's still Kubernetes, so it's going to be some of those setups from an operator standpoint. What is the advantage of running serverless apps on Kubernetes when we already have serverless services from cloud providers? Even here at Google Cloud, we have serverless containers in Cloud Run, which does not run on Kubernetes. It is actually based on Knative serving. So it's backwards compatible with the Knative serving API, but it doesn't run on Kubernetes. So there are providers out there. I believe AWS App Runner is very similar. It basically becomes the managed versus unmanaged argument. If you're already using Kubernetes today, your developers are already leveraging Kubernetes, but you want to simplify their experience, or if you're trying to onboard a new team onto Kubernetes, which I've seen a lot of customers do, a lot of users do, but the developers aren't familiar, by leveraging serverless containers via a Knative or a KEDA or a number of other tools, you're able to simplify that deployment experience for them. So that would be the benefit. If you want to continue leveraging Kubernetes, but you want to simplify the developer experience, that's when you'd want to use serverless containers. And then you can also use a purely managed service with any one of the cloud providers if that is, if your team just wants to say, we don't use Kubernetes at all, we want somebody to manage everything for us, then that's absolutely something you can do. Is Kate's AI infra future or something other projects are there maybe take over this field? I think, as AI becomes more and more ubiquitous, which is inevitable, and we're starting to see more and more people utilize AI, I don't necessarily think it's going to take over. In fact, I think CoreWeave did an interesting talk recently where they talked about how they actually used Knative serving for like serving API models or AI models. So I don't think that's going to change. Generative AI will probably make things easier for developers. Actually, I think generative AI plus serverless is like the dream team for developers in terms of productivity and deploying stuff. So I think we'll see more of that. In an application with dozens or hundreds of microservice packages and containers, there are disadvantage of running them as a serverless container. Not necessarily. There are some issues with service discovery, so services being aware of each other with serverless containers, but we've come a long way, and networking them has become way better, and you can even leverage service meshes now. So some of those issues have gone away. So really, there's no major disadvantage that I could think of other than maybe changing your tooling. Again, when we're talking Kubernetes, when we're talking containers, it's the same experience under the hood. It's just simplifying the experience. From the developer's perspective, you're simplifying their experience by utilizing the serverless containers. All right, great questions. Thank you, everybody.
All right, last call.
Awesome.
Okay. Well, Jason, thank you so much. Thank you, everyone, for joining us. Oh, here was one more comment.
Yes, I'll do that. We'll do this one more comment here. Also, scaling down to 0 is a huge advantage. This serverless containers can be in a warm state in case they are called again. Yeah, you can set them up to a warm state. There are with the different toolings, and I'll probably post something about it online here in the next month or so, best practices on doing that. But there are ways to kind of tune the CPU or tune Kubernetes to kind of allow for a warmer start.
Awesome. All right. Well, thank you, everyone, for joining us. Jason Smith, thank you so much. These will be posted. The video will be posted to the website later this afternoon. And we'll see y'all next time for the next live webinar. Have a great day, everybody.